Lesson 10.4 has some more theorems in it. This time we're talking about inscribed angles. Not necessarily angles that start at the center of our circle like we've been talking about, but these could be angles on the circle. So in our first theorem here, we say that if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. In other words, this angle 1 right here, the measure of its angle is half the measure of that arc. So if the measure of angle 1 is 50, then the measure of arc AB is 100. Okay, so the measure of angle 1 equals 1/2 the measure of arc AB. And we can say the other way that the measure of arc AB equals twice the measure of angle 1. 10.7. We're going to use two colors here. If two inscribed angles, so here's one angle right here, A, B, D, and here's its intercepted arc right here. And if there's two angles that intercept the same arc, so again, here's another angle over here, A, C, D, different angle, but look, same arc. Then the angles are congruent. So angle ABD intercepts arc AD, and angle ACD intercepts arc AD. Because those both intercept the same arc, angle ABD is then congruent to angle ACD. Pretty cool. 10.8. An inscribed angle of a triangle. So here's my inscribed angle right here, HGF. If it intercepts the diameter, then it is a right angle. So here is my diameter right here. And it is definitely a semicircle. So because of that, angle G is a right angle. So FH is a diameter. And arc FJH is a semicircle. Therefore, remember our three little dots, therefore, angle G is a right angle. So our last theorem is talking about a quadrilateral being inscribed. Remember, every point is on the circle. If it's inscribed, opposite angles are supplementary. So here's angle L and its opposite angle is angle N. Supplementary, what does that mean? Remember way back to chapter 1, supplementary means 180. So angle L and angle N are supplementary, means 180 degrees. And angle K and angle M are also supplementary. They will also add up to 180. So let's practice this with some examples. Let's turn the page and let's look at that first theorem we talked about. We want to find each measure. So for angle X, here's angle X right here. And it intercepts this arc, WZ. Our first theorem said that the angle is half the measure of the arc. So 1/2 of 86 degrees. That's 43 degrees. And that's how big this little angle is over here, 43. Alright, the measure of XY. XY. So here's my arc. I'm talking about XY. And look, there's an angle inside over here. It's 52 degrees. So this arc XY has to be twice the measure of the inside angle. And so this arc, 104 degrees. Very good. Alright, let's talk about that second theorem where we have this shape. And at first I want to say, oh, it's two inscribed triangles, but this middle vertex is not on the triangle, it's on the circle, it's inside. So if I'm finding angle R, I want to sort of highlight angle R. And I see, okay, it's over here and intercepts this arc. And then I see I'm given angle S, and I want to see, well, what exactly does that intercept? And hey, they intercept the same arc. They both end at the arc QT. So because of that, I can set these two equal to each other because angle R and angle S are congruent. So to find angle R, let's first find X. Okay, so let's solve for X. It's minus 9, add 13. Oops, that's plus 2. So 3x equals 15. That must mean that x is 5, and that's great, but I want to know angle R. So I need to substitute it in. So off to the side, I'm going to come back over here. Angle R is 12 times 5 minus 13. So 60 minus 13. So angle R is 47 degrees. Awesome. Look at your favorite, a proof. And we're going to use those theorems we talked about in 10.3 and 10.4 this lesson to prove that two triangles are congruent. So first, you always start out with what we're given, remember? Arc LO is congruent to arc MN. And I'm going to use some highlighters to sort of highlight my process. So arc LO is congruent to arc MN. And that is great. However, it doesn't do anything for me right now for triangles because it's part of a circle. But I do see two triangles. I see the two triangles that they're talking about. So since these arcs are congruent, one of the theorems we talked about last chapter is that then their chords are also congruent. So let's go ahead and state that. MN is equal to LO. And that was, I believe it was theorem 10.3. Okay. Now, number 3 statement, I've got one side of my triangle. I also see that I have right here this arc NO. Look at this. I have this angle right here, angle L, and I have this angle right here, angle M, that both intersect the same arc. That's what we just talked about in the last example. So I can say that angle M is congruent to angle L because, oops, not reason 4, because of theorem 10. I've got to look it up. 10.7. Okay, so now I have a side and an angle, a side and an angle. We have to think back to our reasons triangles can be congruent. I can have side, 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 angle, side, angle, angle, side, or I can have side, angle, angle. So I have a side and an angle, so probably not going to use that. This is the same as that. Side, angle, side. So side, angle, I would have to prove MP is congruent to LP. I don't really have any theorems to prove that, so let's go with angle, angle, side. Angle, side, so let's go ahead and prove this right here. We have some vertical angles. We can say that angle MPN is congruent to angle LPO. Why? They are vertical angles. Okay, so I now have angle, angle, side. Are these triangles congruent? Yes. Triangle MNP is congruent to triangle LOP. Why? Angle, angle, side. Move that up so you can see it. We're going to do some more proofs tomorrow in class. I know you're so excited about that. But let's go on to the last one right here. Example 4. We want to find the measure of angle B. So I see right off the hand that this inscribed angle, angle C, it intercepts that diameter, which is a semicircle, which means angle C has to be a right angle. So that means I can make an equation and set my angles all equal to 180. So 90 plus x plus 4 plus 8x minus 4 equals 180. Let's combine our like terms. 9x plus 90 equals 180. Subtract. And 9x equals 90. Let's divide. And we get x equals 10. Is that what we wanted to know? No, we want to find the measure of angle B. So we need to substitute in 10 in place of x. And so 8 times 10 minus 4. So angle B is 76 degrees. Excellent. All right, last example. Let's use our last theorem we talked about where opposite angles are supplementary. So V and S have to add up to 180. So angle V is already 90. So that means angle S, yes, has to be 90. Okay, well that one was easy. Let's look at the other two. Angle T and angle U. Those also are supplementary, but these do not have a degree measure. I do know that 14x plus 8x minus 4, or plus 4, equals 180. So let's go ahead and combine like terms. 22x plus 4, subtract 4, and let's divide to figure out x. equals 8. Is that what I wanted to know? Nope. Sadly, I want to know how big this angle is. Angle T is 8 times x plus 4. 64 plus 4. Angle T is 68 degrees. Awesome. All right, be ready for some more proofs tomorrow.